So now to understand derivatives mathematically, we need to undergo a process called the first principle. So this process is simpler than it looks. What we have to do first is just create a function. In this case, I create another parabola. Now let's say our objective is to find the instantaneous slope at this point. Using the knowledge we already have, we can think about the slope formula, which goes as follows. But of course, knowing the slope formula, we know that we're going to need another point. So let's just choose an arbitrary other point, for example, right here. So if we make a line in between them and we use both of these coordinates in the slope formula, what we're going to do is we're going to find the slope of this line. But of course, what are the coordinates of these two? We can just say that the coordinate of the first one is x, and we can say that the y coordinate of this is therefore f of x. And for the second one, we can just say that the x value is the distance between both of them. We can just call h. So the x value of this is x plus h, together with the y value, which is simply the function, but then using x plus h once more. Now, if we plug in both of these coordinates into the slope formula, what we're going to get, after simplifying a simple bit, we're going to get the following formula. But now we have a formula that will give us a slope of this arbitrary line, but we don't want that. We want the instantaneous slope. So our objective is to use the mathematical concept of limits to figure it out. So how do we do that? We want to make h as small as possible and make it closer and closer to 0 so that we end up getting the slope of this point and the closest point we can build. So our objective is to make h as close to 0 as possible. So you can use this formula to figure out an approximation of your instantaneous slope. The smaller your h is, the closer it is to 0, the more accurate your slope is going to be. But we don't want an approximation. Let's try to get the exact value.